In 10.2, we're going to be talking about solving exponential growth and decay problems, solving compound interest problems, solving half-life problems, solving growth problems, including the number e, the graph of the exponential function involving base e. So before we get started, you need to know, on the test, I will not provide any of these formulas, and you're going to have to know which formula to use in which scenario, okay? If you are talking about accumulated interest on money, accumulated interest on money is the first one, where P is the principal amount of money, the initial starting amount of money that you put into an account. It's going to be multiplied by 1 plus R raised to the T power. The R, typically in every problem, they give it to you as a percent. In the formula, it's going to be a decimal. So you're going to have to know how to convert decimals to percents and percents to decimals. T is going to be time in years. So if they give you 6 months, time would be a half. Okay? If you are talking about savings accounts where you get interest added every 3 or 4 months, semi-annually. If you're talking about credit cards where they are figuring your interest on your credit card monthly, then we're going to have to switch to this formula. Your accumulated is equal to the principal plus 1 plus the rate divided by how many times in a year it's going to be compounded, raised to that number times the number of years. So if you're doing it monthly, the N would be 12. If you're doing it semi-annually, then it would be 2. Semi meaning 2. Okay, does that make sense? Okay. Then we're going to switch over and talk about some half-life with some scientific. It's the similar kind of problems where we have anything with the subscript 0 is the initial starting amount at time 0. 1/2 being half-life raised to the T divided by the H. T is the time period divided by H. That's the half-life. And on any given problem, your H and your T have to be in the same unit to use this formula. Okay? Then we're going to be talking about compounding continuously. Again, this is accumulated money. Principal times E raised to the RT. And again, you can think of that principal as the initial starting amount that you have, where R, again, is a decimal, T is time in years. And then the same kind of thing when we move to your exponential growth and decay, they switch up your formulas. Q is the initial amount of like your radioactive material, E raised to the KT, and K is going to be the constant that depends on the particular application of your exponential growth or decay. If you are looking at the last formula, how do you know if this is going to be a growth or a decay? Think about the problems that you graphed. How do you know if it's going to be a growth or a decay?
It's a whole number greater than 1, right?
Okay, if the base is greater than 1, what is E as a number? Does anybody know? E is a constant number, 2.718. So E is greater than 1. Now, there was something else that we need to look at if it was an exponential growth or decay. If the base was greater than 1, then what do you have to have in the exponent position for it to be a decay? What does it have to be, yeah. So if the K value is negative, then this becomes a decay. If the K value is positive, it'll be a growth. So it's the same idea of what you looked at on those graphs, okay? Now, does everybody have those copied? Then we'll start with our first example. What rate of interest is needed for an investment of $1,000 to yield $4,000 in 10 years if the interest is compounded annually. Which formula are you going to start with? Compounded annually means once a year. So we're going to start with our first formula, 1 plus r raised to the t power. If we want an accumulated interest and we are going to invest $1,000 to yield $4,000, where are we going to put the numbers in that formula? What is A? A is accumulated money. If it's going to yield 4,000, 4,000 is the accumulated amount of money, correct? 4,000 is equal to principal, that's our initial starting amount, which is 1,000. And we need to know if it's compounded, what interest, well, that's the R we're solving for 10 years. In this problem, how are you going to solve for R? Get R on a side by itself. What do you do? Divide by 1,000. How do you undo a 10th power? How do you undo a square? So if it's a 10th power, how do you undo a 10th power? The 10th root. Okay? And there's two ways you can do that. You can say the 10th root of, or you can multiply the number by 0.1. So it's the same thing. On your calculator, how do I get the 10th root? Math, go down to 5. And notice I typed in 10 first. So when I go to math 5, it automatically puts that number as the 10th root. And then I'm going to do 4, and that gives me this long decimal approximation. 1 plus r equals 1.48. And I'm going to keep that in my calculator. I'm still solving for r. So how do I undo a plus 1? I'm going to subtract 1 from the exact value. This is r as a decimal. I need my answer r as a percent. How do I change a decimal to a percent? Multiply by 100 or move the decimal 2 places. So my R value, my rate, is 14.9%. Are you okay with that one? All right, moving on then. Speaking of exponential growth, exponential decay, you can talk about depreciation of a car, half-life, any of those kind of things. We have a barium 140 has a half-life of 13 days. If there are 500 milligrams of barium initially, how many milligrams remain after 26 days? So the formula I'm going to use, Q sub 0 times a half, because it was talking about a half-life, T divided by H for the half-life. What is my initial Q sub 0, my initial value? Yeah, the barium 140 is the name of what we're talking about.
Okay.
So if there are 500 milligrams initially, so the Q sub 0 is the 500 times the 1/2. Now we're going to have to look at something. Our T and our H has to be in the same units. The half-life of 13 days, and we want to know how long after 26 days. So if the half-life is 13, then our H is going to be the 13 with the T over it. And we need to know the time. And we need to know how much is left Q. So there's my formula. First question, after 26 days, where does the 26 go? Yeah, for the T, because it's days, so the half-life days have to be the same. And I'm going to solve for the variable Q. And what I would do if I were you all, I would just type that all in at the same time, so you do not have to worry about the PEMDAS, the rules in order. Now I have 125. What? 125 what? What's my units? Milligrams. All right, I'm going to do the same thing. This time I'm going to do after 100 days. I've already got it in my calculator. I'm just going to push the blue button and enter. And I'm going to change the 26 to 100. The second answer I have is approximately 2.4 milligrams after 100 days. Any questions on that one? I'm not going to waste my time typing it back into the calculator because I'm doing the same thing. I've just changed one variable. Everybody okay with that? All right. Suppose that in a certain culture, the equation is 15,000 E raised to the 0.3 T. It expresses the number of bacteria present as a function of time. We want to find the initial number of bacteria. Initial means time when. What does initial mean to you? The starting point. When time is what number? Time zero. Yeah, at time zero. If I substitute the zero in for the T, and hopefully all of you have already realized that this is an exponential growth problem. So when I substitute the time zero, what number do I have left? What is in the initial position? 15,000. E to the 0 power is 1. 1 times 15,000 is 15,000. Second question, what's the number of bacteria after 3 hours? Same problem, except now I need 3 hours. 15,000 E raised to the 0.3 times 3. You know there are 2 E's in your calculator, yes or no? One of them, you use the blue button and the natural log. That one has an E to the X power. That means you're raising it to an exponent. If you do the E button that is over the division problem, that one you're going to have to raise it to the power of the 0.3. Okay? So our answer, 36,894, and we are talking about what? Bacteria. Make sure you give me the units. Everybody okay with that? On these assignments, this assignment, all of the problems are either going to give you the formula or they're going to give you problems with the formulas you're going to have memorized. And it's just plug it into the equation and work it out. So they should not be difficult word problems, okay?